Hey guys, hope you're all doing well. Tonight I'm actually going to be showing you something a little bit different here. So I've been experimenting with the electronic fuel injection on the Datsun 280z, as I've named it. And I started assembling the car. I've got the pedals and everything out of it, and I'm salvaging as much as I can. But one of the things I got out of it here, and I wanted to see if I could make it work, was the actual fuel injection system. Because I just really like this stuff. I enjoy messing with electronics, vintage electronics. As some of you have seen my Synth Pro channel, I'm not afraid of this stuff. Actually, I really enjoy this technology and just the stuff that was around at this era. It's just a lot of fun to mess with. But anyways, I've managed to reverse engineer some of it. I figured out how it works, and I've actually made it run here on the floor. And I'm just going to kind of show you how this thing works. I'll go through the parts, and I'll kind of show you how you can test your harness if you're questioning if you have a harness problem. Just some things you can kind of check and see. Now, some of these would require an oscilloscope to be able to see. Of course, we're not getting that deep. I'm going to show you kind of how I've done it, and I can just kind of show you how this thing works. So we'll start over here at the airflow meter, which is what this big thing here is. And what it does, it just has a little flap in there, and it changes the resistance based off the vacuum pulled through it. Basically, the more throttle you give it, your butterfly valve opens in your throttle body, pulls more air through this thing, pulls that flap, changes the resistance. And then what the ECM does, the electronic control module, is it will change the pulse width of your injector time. So it'll widen it so the injectors are on for a longer span of time, giving you more fuel delivery based off the resistance change there. So that's what this thing does. It also has an air temperature sensor, and so it actually reads the air temperature as it comes in as well to help compensate for fuel based off the density of the air. So that's also what it does. Of course, then you got the electronic control module, which is basically the heart of the system. It's not really a computer. It's really more of analog circuitry made up to read the resistance and the other variables and combine them to make a summed output of what the injector pulse needs to be for the given state. It's really what it does. So you got that. Then you got this device here, which is the dropping resistors. And what it does, its whole function is really just to protect the injectors. It's a resistor bank that current limits the injector coils. So it protects them. It also helps lower the voltage on them a little bit. So it just kind of helps with your injector coils from getting overheated or burn out as they run. So that's what the function of that is. And then of course you got your injectors. I've got these injectors plugged in out of the 85 Corvette of mine. So I just got those plugged in just to test this harness. So you got those, and then you've got what would have been the cold start sensor, which actually reads the coolant temperature, and if it's cold enough, it makes your, I think it's like a thermotime switch, but it basically makes your cold start injector activated. And then you've got another wire here for your coolant temperature, which once again helps with the pulse width of the injectors based on the coolant temp. If the engine needs to be in a cold start, or if it needs to, or if it's already warmed up, it'll change your injector pulse to compensate for the engine temp. That's what its job is. So that's really the system of this injection system. It's pretty simple. It's not very complex at all. One reason I really like these old cars, and it's just simple. It's not all this software and junk that gets in the way. So we got that. Now we got a secondary entity really of this car, but it's important. And that is the electronic ignition, which is this little box you see here with a distributor. I've got a whole video going over this on my other channel, but I'll share a link in the video description for those that want to check that out. I've got a video both on how the electronic ignition module works, as well as how the vacuum advance works, for those that might be curious about that. But once again, I'll put those in the description of this video. So anyways, I'll kind of show you the wiring here, because I had to kind of reverse engineer this thing a little bit. And I'll kind of show you where this stuff's located on the car, and that way you can kind of follow out where I'm at with this thing. So we'll start with the ECM. It bolts on the kick panel on the driver's side, And then this harness comes out. Of course, you can see where it comes outside the car with this grommet that's all ate up. So this would, the drop-in resistors would be over on the little accessory panel next to your clutch master cylinder or your brake master cylinder if you don't have a clutch, if yours is automatic. You'd be over there in that little corner and that little accessory lid you open. And then, of course, the airflow meter, it'll be on the front of the engine with the intake filter, the breather box, and your throttle body. It kind of goes between those two things. And of course all this harness is on top of the engine. So that's pretty much what it is. And the ground actually on this particular car bolts to the intake. So that's actually your basically your master ground for your fuel injection system. But anyways, we'll go back to this connector here because this is kind of important to know what this thing does here. So this is located by the steering column under the dash. And you got 3 green wires and a black wire. And I'll show you what I found out. I kind of reverse engineered this looking at the schematics of the car. And so I'm actually only using 2 of these wires for this test. And the 2 I'm actually using is what I'm calling G2 and B, which is for black. So green 1, green 2, green 3. Now the first wire of this jack right here is actually for the start. It's on the plus side of the starter, so when you turn the car over, I think what it's supposed to do is deliver a little bit more fuel during crank, so it is easier to crank up. That's what that wire does. Well, I'm not using that. As you can see, I've got it not connected. The G2 wire is the important one, because this one actually is what energizes the relay over there, which I forgot to mention. That's the actual master injection relay, and it's located on the under the hood on the little relay panel is where it's located. And so G2 is actually what energizes the coil in the relay to power your electronic fuel injection circuit. So that's very important, which that's where I've got the plus voltage coming in there on that red wire you can see. Then we got G3, which is associated with the fuel pump power. Since we don't have the fuel pump system, we're not worried about that right now. But that's where basically you get your fuel pump signal saying, okay, it's running, you know, I need fuel. That's basically what that's for. Now this black wire is also critical. And the black wire, what it is, it's actually the ignition signal. So this comes to our ignition module. So what it does is the ignition module's job is to create a pulse to turn on the ignition coil, but it turns it on by making a ground connection. That's how that works. So what happens is I've got it connected to the basically the negative side of the coil, and where the coil would be, I don't have an actual coil because I don't need the high voltage, but I've got it running over here and I've got it hooked to the black wire. Now the point of this is actually how the injection system gets a clock to know the engine's turning over and what revolution the engine's running at to clock the injectors for the correct pulse. So that's what the black wire does. So so G2, as I'm calling it right here, and B are the 2 critical connections that you have to have in order to make the relay work and to actually make this injection system have what it needs to work. So now what we'll do, we'll go over here and I'll just kind of show you how I've got this thing wired up. So looking at the relay, I'll bring you over here now to this side. So as you can see, this is a long, kind of long harness here. So it comes out of the firewall around this grommet here. This wire runs along the firewall, all the way along the firewall. This goes up underneath the relay panel as mentioned, which is actually, I can show you the panel, I've got it right here. So it goes inside this panel here, which bolts up under the hood. So there's where that relay goes. And then what happens is you got a connector, but I've still got this piece of plastic right here that goes by the battery. So this kind of sets by the battery, bolts to this. And you can see kind of where it was clean. And that's actually where your main plus voltage comes into your injector harness. This is where the fusible links would be, and it'd be connected to the positive side of your battery. So that's basically the system there. That's kind of what makes it up. But now what I'm going to do, I'm actually going to apply power here and I'll show you. So first of all, we got this connector here, which what it does, I'll connect it to the positive. So right now we have the ignition module. Should have the ignition module. See if I got everything connected right. Yeah. So you can see here the little light flashing represents the coil. But you can see we have nothing with the injectors. I got a little LED plugged in right there. But you can see that we don't hear the injectors or anything. Although I've got power over here. Now, what I'm going to do here is I've got this yellow wire that's going over there to our relay power for our injection system. This will be like key on, basically. So we'll plug this in, you'll hear that relay click, as you can hear. So now, we've got power on the relay. So now when I rotate this, you can hear our injectors pulsing. And it's for every third trigger of the distributor rotation. As you can see, three flashes. It triggers the injector on the third trigger. So 1, 2, 3, 1, 2, 3. And you can see I'm just rotating this by hand off the rotary button. And you can hear that thing pulse. Now I've done some experimentations here to see if you need everything connected in order to get a pulse. You don't. I can actually unplug the airflow meter. Now needless to say the car would run like crap, but you can disconnect that. We don't have any sensors plugged in. As you can see, I'm still getting a nice pulse. So even with your airflow meter and everything disconnected, as long as you've got your relay power and your relay contacts are okay and you've got a distributor signal, you should have injector pulse. If you don't, then that's where you need to kind of look and see if you've got the ignition pulse into your harness, because this harness goes quite a ways away from the actual distributor. And this box is located on the passenger side kick panel. It's actually where this box is, so it's got to go quite a ways across the dash here. Hey kitty. But anyways, that's kind of how it works. And but yeah, so if you don't have a pulse, check your harnesses. And then also you could have a bad ECM like I had in this particular car. So anyways, I just thought you guys might find that kind of interesting. It's you don't see this very often. And once again, you can see just how simple this system is laid on the floor. So not much to it here. But anyways, guys, hope this helps some of you guys out. Thanks for watching. There'll be more here to come here very soon. Take care.